Well, question 6, June 2015, core 1. Worst done question of the lot, simply because you couldn't remember your GCSE formula. I'm not going to spend A-level teaching time reminding you how to find areas of squares, rectangles, circles, or things like that, or even finding out cylinders. This is things you have to remember how to do. We're trying to find the surface area of this thing. It is an open top one, so there's no area at the top here, but there is a circle at the bottom there. And you must remember the circle formula is pi r squared. We've also got this curved surface area here, and this is a rectangle. This rectangle is h high, and along here it's the circumference of that, so 2 pi r. So there's the formula for that, but very few people got that far. That, you've been told, is equal to 48 pi. So we equal 48 pi. Now a bit of manipulation. Notice there's a pi in everything. So let's get rid of that pi. That leaves us r squared plus 2hr equals 48. We want h all on its own. So let's take away r squared from both sides. And let's divide by the 2r. And there is something for h. Now we have to throw that into the volume formula. Again, the volume was something you should have remembered from school. The volume is the area of the bottom down here, which we've already decided is pi r squared, times by the height. Without that formula, you can't do this part. So we now drop in the h we had earlier into that bit there. So we've got that the volume is pi r squared times by 48 minus r squared over 2r. And this time we know what we're aiming for, so we can try and see how things go. Let's cancel this r here with one of those there. That cancels that out. And we now got 48 divided by 2, so that's 24 pi times r. Take away pi times r squared divided by 2. And that is what we were trying to get here. Well, you might have lost all those 5 marks, but you shouldn't have given up on the question, because the question has given this show that so that you can do these 6 marks here without it. A lot of people did. Differentiating here. We're differentiating with respect to r, so it's the r we're looking at there. The power goes down by 1 to nothing. Here, we're timesing by the power, so we've got 3 pi over 2, and the power goes down by 1, so we've got the r squared there. We go differentiating. Well, when is it stationary? It's stationary when this is equal to 0. Let's add this to both sides. Let's divide both sides by pi, times by the 2, it's 48, and divide by 3, so r squared equals 16. If r squared equals 16, then r equals 4. It can't be minus 4, because you can't have a radius of minus 4. 2 marks. We need to check whether it's a maximum or a minimum as well. To do that, we have to differentiate again. Just looking at this thing here, that's just a number now, so when we differentiate again, that will disappear. d2v by dr squared will be times here by 2, so we've got minus 3 pi r. The r value that we're looking at is 4. Drop that in, so we're getting, by dr squared, we're getting minus 12 pi, aren't we? 3 times 4 makes the 12, minus 12 pi. Well, clearly that's negative. Because it's negative, therefore we have a maximum point. There's the other 2 marks. Mark scheme there, and the examiner's report, it says at the top, many candidates seem to have forgotten the formula for the curved surface area of a cylinder. and confused it with the formula for the volume. Lots and lots of people had trouble.